Hello, my name is Andrew Lenart and this is my first lab. So, what is the goal of this lab? It is to analyze an object moving at constant velocity without changing direction and create position versus time graph, and we want to prove whether or not the ball is in fact moving at constant velocity. We will then make another position versus time graph of how the ball would move in an ideal world, and compare the two outcomes. So, to analyze the motion of the ball, I recorded a soccer ball rolling on the ground at constant speed and analyzed it using the tracker software. And then I created a model using GlowScript to base it off ideal physics and base it off of the momentum principle, position update formula, and understanding that net force would be equal to zero, which will be proven later. Results: the model and analyzed data show a strong resemblance, proving that the object was moving at a constant velocity. Both graphs had a negatively constant slope, and this proves the object was moving at a roughly constant velocity. So here's my video of my soccer ball. As you can see, it moves at a relatively constant velocity. I uploaded this video into Tracker. As you can see, it's upside down, but this doesn't make a difference for the analysis. And I first had to set up the conditions. So I first set up the scaling factor as my laptop width, as it can be seen here in the blue, as 0.374 meters, and set up my axes as the starting point of the ball, shown in pink. I then analyzed the position of the ball at 26 equally spaced time intervals and only recorded long after the ball has left my hand, so it's moving at an actual constant velocity. And the ball showed constant velocity during the entire recording. Here are the results. As you can see here, the most important are that my initial velocity is negative 1.87 meters per second in the x direction, the duration of motion is 0.867 seconds, and it's displaced negative 1.562 meters in the x direction. So scientific principles used in my model. So my model is supposed to represent the ideal world of what would happen. And the net force is equal to zero, and how we realize that is that we ignore friction and air resistance, so the only two forces are the force of gravity and a normal force, which are equal and opposite, so they cancel, giving a net force of zero. I also used the momentum principle, and I used it to find a velocity of the ball after a change in time delta t. But because the momentum principle is Vf is equals to Vi plus F net divided by m delta t, the velocity will stay constant because the net force is equal to zero, so Vf is equal to Vi. And I also use the position update formula to update position of the ball for duration delta t. So position final is equal to position initial plus velocity delta t. Now I use a GlowScript to create a model of the ideal world, and it simulates how the ball would move in a perfect world, as I said. So it uses values from the video analysis, so position, velocity, and duration of motion. And then I also use the position momentum principle and the position update formula to simulate movement of the ball, as can be seen here. I use these formulas, and the F net is equal to zero. And it will run this program and print out the values of the position and time for each time step and create a position versus time graph. So what could I conclude? So I plotted both results onto a graph in Excel and saw that the model and tracker data showed a strong resemblance. Model predicted that it would move negative 1.63 meters, while it actually moved negative 1.562 meters, so it's a small error. And we concluded that the ball did move in fact at a relatively constant velocity because the slopes of both the model and the tracker data is a negatively linear slope, or roughly. Possible sources of error could have been in the friction in the floor unaccounted by the model, or even human error when I was recording the positions. And ways to improve upon this is I could roll the ball on a smoother surface instead to limit the amount of friction on the ball. And as you can see here, this visualizes the amount of error. And you can see here the velocity of the model is shown by the orange line, what should be in an ideal world. And the blue points show on tracker. So the blue points average out to be around negative 1.87, but as you can see here, there's error as it's not moving at a perfectly constant velocity. Again, this could be from friction or even human error. So final questions. What if we flipped the variables to alternate axes? Well, the initial position and final positions would differ, as well as the direction of motion. But most importantly, the slope of the position versus time graph would be roughly linear, signifying constant velocity. And next, is it possible to say how many forces are given in a net force of zero? And while the ball is moving, we say that's a net force of zero because there is a normal force and force of gravity canceling each other out. But in reality, there's also friction and as well as air resistance acting against the way of motion. So in reality, it's not a net force of zero. Anywho, thank you very much. This has been my first lab, and thank you for listening.